Okay, so I wanted to tell you guys about a project that I made. So I had this problem. I put up Christmas lights, and then I needed to uh, go out and flip the switch to turn them on or turn them off in the morning and in the night, so that they would be on during the nighttime and off during the day. So I wasn't just wasting a bunch of electricity on. We have some white lights, so like that you wouldn't even see them. So for the first couple of days, it worked pretty well because it was the weekend. So I was able to just turn them on, when I got up in the morning, and then turn them off, or turn them off during like turn them off in the morning when I got up, and turn them on during the nighttime. Um, but then like the next day, it was the work week, and I'm the type where even though I try really hard, I'm running late to work every single day. This isn't helping. So if I tell you a little bit about how the lights are set up, um, we have a detached garage, and it's got a plug on the side of it. It's our only outdoor plug for some reason. So we plug the extension cable into that, and it goes to the lights. And then the way that that plug is controlled is there's a switch on the inside of the garage that you flip up or down to turn on or off the lights. And that can be convenient. For a little while, we thought it was broken because we didn't realize it had a switch inside. And so the unfortunate thing is that when I'm leaving for work, my car's parked outside the garage. So I have to open the garage or open the garage door and then flip them on or off and then go back out to my car. And that wastes, like 30 seconds to a minute. And sometimes in the morning, I literally am clocking in the moment that like it's on time. So, um, the bad thing with it being a switch is that means that we could like leave it on, and they do sell a product that automatically turns on and off your outdoor lights, but it's like 15 or 20 bucks, and it's already made. So I mean, what's the point? I can't make a project about it. But the main thing about it is I just didn't want to go out and figure it out, and also I didn't want like any sort of instance of it getting broken because of it's not waterproofed enough or something. So uh, the good thing about it is that because it's a light switch, I had this idea of servos are conventionally used for changing the flaps on an airplane, like on an RC airplane, and so they can pull pretty hard for some of these small airplanes to be able to, overpower the wind basically. And so I thought, well, this light switch isn't a super firm light switch. Maybe I could just drill a small hole in it and then attach the servo to it. So that's exactly what I tried to do. So yeah, at this exact same time that I was thinking about how to figure this out for my project, the servos that I ordered on AliExpress like 2 months prior finally showed up. I decided to use Arduino Uno because I had one on hand and I've been meaning to learn more about it. Um, and then I also had just some switches and all sorts of other random components that I got in those like starter kits. And So I did some prototyping on the board. I'll show it here so that you guys can see. It's just a breadboard and the Arduino, and I'm testing out different things. I've got LEDs lit. So I needed to be able to encode what time it was, what time I wanted the lights to turn on, and what time the lights needed to turn off. And so rather than having like an LCD screen or like a complex set of buttons, I just wanted it to have an LED that flashes to let you know what phase you're in. And then you press the button the number of times in like 24-hour time. So you just say like the first one, for instance, if you're setting it for like 2:22 p.m., that would be 14:22. So when it lights up the first time, you press it 14 times, which is not the most convenient, but it's the easiest way I could think using just buttons and LEDs. And then it blinks at you, and then you press it 2 more times, and then it blinks at you again, and you press it 2 more times, and now the system knows that it is 2:22 p.m. essentially. So then next you have to set the on time, and then you have to set the off time. So it's all encoded the exact same way. You just use slightly different buttons. I made the current time and the turn on time to be the top button, and the off time to be the bottom button. Let's see what's next. Oh, and so with the Arduino, I thought originally that it had like a clock, kind of like a Raspberry Pi, but I realized shortly after programming on it that it's actually a lot simpler than I thought it was. So it's just got a clock that says how many milliseconds have passed since it turned on, which is a little bit less helpful. I have a little bit of experience with this kind of thing using Unity, keeping track of time through timers and stuff like that. So what I did was I created a thing that basically says like how much time has passed since the last time we ran, and it takes the last milliseconds and this milliseconds, and then it subtracts them out. And that seems to work pretty good. I think it still has a little bit of bugginess. It was inaccurate occasionally. So we've got milliseconds being counted into, I just have it as total seconds because seconds are easier to do math on. You can convert, hours, tens of minutes, and minutes down to seconds pretty easily. Oh, okay. So the last problem that I thought would be a bigger problem, but actually wasn't that big of a problem, is that the value that holds milliseconds, called millis, it can only hold like 43 days worth of milliseconds or something. And after it rolls over, you need to handle that, or else your system will get confused because it'll not know how much time passed between them. But I found it was actually really simple. You just put a little thing that says if the current value is less than, no, if the last value is, actually I don't remember exactly how it goes, but one of them is less than the other one. Basically, it's not supposed to go that way. So then the system automatically knows to like be careful. Really, 43 days could be fine if you put up your Christmas lights at the right time. So I had a way of keeping track of time and a way of encoding the time that you wanted into the board. So now I just need to test to see how servos work. And I found out that servos have a cool library on the Arduino. So it was pretty easy. I just made it move full degrees to make sure that I could make sure the light switch went down. So I designed a little case for this that I wanted to set up, and I didn't record it because I don't have a time-lapse kind of set up on my 3D printer, but in the future I want to have some sort of camera on the 3D printer so you can see the prints as they print all the way up. But it was just a simple case. It was just function. That's kind of the theme of this whole channel, is just function first, and then after that we can work on more prototypes that make it look fancier. But right now it's just function. So I then soldered all the cables together, and my solder work is not great. I'm still trying to get better at that. I haven't soldered since high school when we did soldering in my IT class. I was in a technical school as well, so it was like, I did IT half the day and then I did high school the other half of the day. And we only did soldering for like a month or two out of the 2 years. So I didn't get a lot of practice. I need to get some more flux and stuff like that. But for now, the solder joints work good enough. So, I put the box out in the wall and I tested that the servo reached, and then I put all the electronics in and tried to close the lid, and the solder joints kept breaking, and I'm stubborn. So I tried probably like 5 or 6 times to just make them fit, and kept breaking cables or kept breaking solder joints, having to go back in the house, resolder them back together, and then went back out and tried to cram it back in the box. But I have too stiff of wires, and I didn't account for any wire space in there. When I 3D modeled it, I only 3D modeled for Servo, Arduino, board. That's it. I didn't account for the fact that it's got components and cables and all that. So it was a disaster. I ended up printing I didn't want to waste too much more filament because I'd already wasted like a lot of filament prototyping that box to begin with. So I 3D printed just a spacer that matched the shape of it and just went right on top, and I just super glued it on top. And then I drilled the lid into that. So it looks ugly, and I could make it look nicer, but like I said, function first and then form later. But so I've got the box out in the garage. It's got the electronics in it now, and when I first tested it, it didn't work because it was broken again, so I had to go back in and fix it. But then when I put it back on, it actually worked. And after I kept forgetting it was 24-hour time, I thought there was like a bug in the system or something, but it was just that I needed to encode the time correctly, and then it was fine. Once I encoded the time correctly, everything worked great. You can see the lights here, they're turning on. And then I have it set for just like a minute later, so we wait a minute, and then they turn off. And I did encode an override button, mainly just for when you first encode it, because if you encode it during the daytime, it doesn't know that it needs to be on. So it'll just default to like the middle or like off. So I press the override button, and it I was pretty happy with it. It actually worked. You press the override button and it just flips the switch. So if it's the daytime and you want them to be on, you can press the button and it turns on. If it's nighttime and you don't want them to be on, you can press the button and it turns them off. But yeah, that I'm going to show you a little bit of a video where I encode it fully from the beginning. And then after that, I guess we'll just move on to the outro. Okay, so let's plug this thing in. I'll show you how it works. So we code it in 24-hour time. So first we start with the current time. So we'll say 2:22. So it's tens place, then singles place. Now we want it to turn on 2, 3, 4 at say 4:30, sure. So that's 4:30. So it'll do the 0. It'll be the singles place, and we do 0. And then we want it to turn off at 1, 2, 3, 4, 5, 6, 7, and then we'll say maybe 7:30. And so then now it's all set. Well, it's got to do the 0. So now it's all set. So now it's waiting. So usually because the servo starts in the middle position, I have to just hit one of these buttons. So we'll turn them off for now. And then I'll show you what it looks like when the timer ticks over into each one. I'm trying to find a better way to record because I've got so much cool stuff I want to make and want to show, but I'm really not a huge fan of like the editing. I'm just not very good at it, and I don't have a lot of free time. So if I can reduce the amount of time it takes to make videos and still make them decent enough, I'm thinking maybe at least like stream quality, where it looks like, you know, it's kind of recorded like as if I was on a stream or whatever. If I can get to that point, then I think that I'd be happy with the videos, and I could put out more content that people would actually want to see, because I know I'm interested in this kind of stuff. Any of this kind of stuff is super cool. I like making these little projects. Oh, here, I'll show you the final electronics. I completely forgot that I had this over here still. So I had to take it down, obviously, because it's past Christmas by quite a bit now, but I'm thinking about doing a project like this every year, Christmassy involved. Like maybe I'll override this and like make it Raspberry Pi enabled, and then I can connect it to the internet, and then maybe one year I'll have like an LCD screen, and then, you know, one year it's like a touch screen to input the information, or I don't know, something like that. That's my thoughts. But so this is the front panel. This is the override button. I 3D printed little caps for the buttons. You can see it's a mess of spaghetti back here. This is the button that you use to program the current time and the on time. And then this is the button you use to program the current time and off time. These buttons light up to show you which one is enabled. So like if the first one's lit up, then you're programming current time, on time, off time. This one lets you know that the lights on the outside are actually on. So if you press the override button, this will light up. And then if you press the override button and the Christmas lights are off outside, then it will turn off. I soldered it all to this just little board. You can see I just tried to create it simple. And then I thought it was cool. I made these little connector pieces, and so then they kind of like plug into the Arduino Uno. And then it's plugged in. So that way then you can remove it easily. The servos I've been using, just these little things. If you guys know where I could find even smaller servos, I don't know if they exist. I've got other projects in the future that need really small servos that don't do much work. They're just kind of there. Yeah, so I guess we'll move on to the outro. I know I said that earlier, but... So yeah, that was a pretty nice project. I had lots of fun working on it. Some stuff was a learning exercise. Definitely a learning exercise. I learned quite a bit, so what are you doing? What does it look like I'm doing? Why so early? What do you mean early, dude? It's February. Why don't you go play some golf? But yeah, so I mean, if you guys like that video, you hit like and subscribe. I've got my other socials in the description. I'm continuing to post this kind of stuff, as well as hopefully some more game dev stuff in the future. So yeah. See ya.